Welcome to this video. I'm Dr. K. Usha, Assistant Professor of Statistics, Sri Sharada College for Women, Salem. So in this video, I'm going to talk about t-test for single mean. So first, we will see the definition of t-test for single mean. The one sample t-test is a statistical hypothesis test which is used to determine whether an unknown population mean is different from a specified mean value. So the one sample t-test means here we are taking only one mean value only. Suppose the two sample means we can use the two sample mean formula. Suppose more than two mean means we can use the ANOVA model, which means F test. So here we are taking only one sample, which means one mean. So based on the unknown population and specified mean value, we can find the given mean value is accepted or rejected using the test procedure of one sample t-test. Let's see that assumption of one sample or on sample t-test, assumption of students t-test. So the parent population from which the sample drawn is normal. So we are taking the sample should be the normal, we should be taken from the normal. Then the sample observations are independent, which means the sample is random. So the observations are independent, we can choose the observations randomly. Okay, next one is the population standard deviation is unknown. So the population standard deviation sometimes we get unknown or sometimes it's a unknown. So based on that we can find it. So next one is the testing procedure for t-test for single mean. The first one is the null hypothesis. So here we set up the null hypothesis H naught, which means there is no significant difference between the values. Which means if we are taking two values, so for example, we can take that before the coaching the student mark and after the coaching student mark mean value. You can take that. We can compare the two values, so before and after. So we can find that for that we can frame the null and alternative hypothesis. So before and after there is no difference in the student's mark, that is the null hypothesis. Then alternative hypothesis means there is a significant difference between the values, which means before and after the test the students marks will improved. So that is the alternative hypothesis. So after that, we need to fix the level of significance. Level of significance, it is denoted by alpha. So here we have to choose the level of significance. Alpha value is the 5%, 1%. Based on your problem, you have to choose the level of significance. So default, we can choose the 5% level of significance. So next one is the test statistics. First, we have seen that null hypothesis, alternative hypothesis, and level of significance. After that, test statistics. Here we are taking the one sample t-test formula. So for this, so we have to denote this symbol is the small t, not in capital T. So this is the one sample t-test. Small t equal to x bar minus mu divided by s square root of s square divided by n minus 1 follows t n minus 1 degrees of freedom. So here x bar is the sample mean value, then mu is the population mean value, and s square is the standard deviation value, then n is the number of observations. So after get all the values, substitute these values in this formula, we can get the one value, that is the t value. So this is the calculated value. Then Tn minus 1 degrees of freedom is the tabulated value, which is given here. So you see here. So now we can see one by one. That next one is the conclusion. After the four steps concluded, we go for the conclusion. We compare the computed value of t in step 4. This is the step 4. This is the computed value which is denoted in small t with the significant value, that is the tabulated value t alpha. So t alpha is the significant value or tabulated value. This value is ready to use, already tabulated this value. So tabulated value, from this value we can compare the this calculated t value and t alpha value. Based on that, we have to write the conclusion at the given level of significance alpha. So here alpha means 1%, 2%, 3%, 4%, 5%. So more than that. So here we are default choose the 5% level of significance. Based on that 5%, if 5%, 1% or 3%, now we can choose based on that 5% value, we can choose the alpha value. So that is the level of significance. So after that, we come to the conclusion. If modulus of t, here is the we put modulus t or t. So what the purpose of putting modulus of t? The modulus means we know that negative values become the positive values. For that purpose, we are using modulus of t less than or equal to t alpha. If the calculated value of t alpha is less than the t, we say it is not significant. The null hypothesis H0 is accepted at level of significance alpha. So which means the modulus of t, which means our calculated value is less than the tabulated value, means the null hypothesis is accepted, which means there is no significant difference between the value. I already told an example now. So after and before the test, students score will increase or decrease. So which means there is no difference before and after the test. After the test, that is here we can conclude. Then next one is the, so modulus of t greater than t alpha, which means there we have seen less than, here greater than symbol. If the calculated value of t alpha is greater than the t, we say it is significant. The null hypothesis rejected at level of significance at alpha. So here what is given now. So if tabulated value is greater than the calculated value, now the hypothesis accepted. Otherwise, it is the rejected. So we conclude that the before and after the test, students' marks will improve. That is the given for here. So which means the null hypothesis rejected, which means an alternative hypothesis H1 is accepted. That is the given in this. Given this. So if you want to calculate one problem for one sample t test, now we have to follow all the we have to follow the test procedure, all the 5 steps, so we get the answer. So we will see the example for this. For one sample t test, the mean weekly sale of soap was in a departmental stores was 146.3 was per store. After advertising campaign, the mean weekly sales in 22 stores for typical week increased to 153 and a standard deviation is 17.2. Was the advertising campaign successful? So what they given in the problem, the mean weekly sale of soap was in a departmental store was 146.3. So already is given mean was per store after advertising. So this is after advertising, it was increased in 22 departmental store as 153.7. So we can take an as the, this is the before the advertisement mean value, that is the population mean value. Here the after the advertisement it increased the value, that is the sample mean value 153.7 and the standard deviation for that 17.2. So here we have to check whether the mean value increase or decrease based on the advertisement. Let's see that. So for the given problem, first we take the solution for this problem. Given n equal to 22, which means the sample size at a 22 departmental store, so we took as the n equal to 22. Then standard deviation is the 17.2. Then x bar is the sample mean value 153.7, and then population mean value is the 146.3. Then we have to write the null hypothesis, alternative hypothesis. Then we need to choose the level of significance. Also we have to do all this to complete this test. So already we have seen the procedure for one sample t test. Now we are applying that procedure here. So first, this is the null hypothesis. Here we need to form the null hypothesis. The advertising campaign is not successful. That is H naught mu equal to 146.3. So null hypothesis means there is no significance. There is no significance, means there is no mean, which means we always we put null hypothesis to the equal symbol. So for all problem we have to put the equal symbol. So there is no significance with both mu and 140, which is mu is the equal to this value. Okay, next one is the alternative hypothesis. The advertising campaign is successful. So here is the not successful, here is the successful. Note this point. So this is not successful means null hypothesis, is successful means alternative hypothesis, which is denoted by H1, mu greater than 146.3, which is the right tail test. So one thing you have to keep in your mind, the thing is that based on the alternative hypothesis we have to choose the tail, which means stable value. So here we are choosing the right tail because the problem they are given, and what they given after an advertising campaign, the mean weekly sales in 22 stores for a typical week increased. So which means when as they given increased after the advertisement, the sale was increased. So that's why we are putting here greater than simple, that is mu greater than 146.3. Here not here, just we are putting equal only. That means null hypothesis. Alternative means greater than simple or less than simple or not equal to simple we have to put. So for if greater than means we can choose the right tail test. Suppose here less than means we have to choose the left tail test. Suppose not equal means we have to choose the two tail test. So this right tail test and left tail test we can call it as the one tail test. Okay. So after framing this null hypothesis and alternative hypothesis, now we have to choose the level of significance. Here I took 5% level of significance because in the problem they didn't mention a level of significance. So default I chosen 5% level of significance. Say suppose if they mention means we need to calculate that level of significance only. So now go to the calculation. So the next fourth step is the test statistics. So small t equal to, here is the, we know the formula t, one sample t test formula, x bar minus mu divided by square root of a square divided by n minus 1, which follow n minus 1 degrees of freedom. So that formula we are substituting all the values. For x bar value is the 153.7 minus mu value is the 146.3. Then square root of standard deviation value is 17.2. Here we are squaring that value divided by then sample number of sample 22 minus 1. So after simplification, what we will get? We will get the t value. First we have to subtract the numerator value. Then we have to find the denominator value. First square the standard deviation value and divided by the total number of values. Then take the square root for this value. Then divide the numerator and denominator. We can get the t value t equal to 9.03. So this is the calculated value. It is denoted by t. Okay, now come to the conclusion part. So for the conclusion, we need to compare the two values we already seen in the procedure. That is the this degrees of freedom value T21, and which is the tabulated value. This is the calculated value. This is what so far we have done is the calculated value. First, for comparing that, we need to get the tabulated value. For the tabulated value, T alpha for 21 degrees of freedom at 5% level of significance for single tail test is 1.72. So this value, so given in the given in the t-test for in t-test table, from the t-test table we can take the alpha level of significance 5% level of significance value for 21 degrees of freedom, because we need to subtract 22 minus 1 from the sample observation n minus 1, which is the 21 degrees of freedom. We got to 5% level of significance table value is 1.72. Now compare the compare the calculated value 9.03 and the tabulated value 1.72. Comparing this, the tabulated value is the less than the calculated value. So it is highly significant, which means there is a significant. Hence, we reject the null hypothesis and conclude that the advertising campaign was definitely successful in promoting sales. So what we conclude that, so since the tabulated value is less than the calculated value, we reject the null hypothesis, which means accept the alternative hypothesis H1, which means after the advertising campaign, the departmental sales was increased. So that is the conclusion for this problem. So we can use this one sample t test for a small sample test for whenever we have one sample mean, we can use this this sample test. Suppose we have two sample test, so two sample means we can choose the two sample test. Suppose we have more than two sample means we can use the ANOVA test, which means F test. So so next one, references. So from this presentation, I took the problem and everything is from the Gupta and Kapoor book, Fundamentals of Mathematical Statistics. In this book, they given everything in the detail, applications of t-distribution and t-test for single mean, assumption and problem. Then more problems they given. So you can take this book and work out the problem. Then further in this video description given links for material and reference, and also provide quiz links also, so students take the quiz test also. Thank you for watching this video.